Efficiency tells us how useful something is or how effective something is. And in simple terms, nothing is 100% efficient. If we have a look at this simple system, which I've begun to draw, we put power into it. We expect to get power out. And I'm just going to lose that pen because it's rubbish. So we get power out. But usually in almost all systems there are losses. So let's just take an example. This could be an electrical motor, and it may take power in to make it run, but in the motor, the windings of the motor will get hot. We don't want that to happen. We're having to pay for it. There will be air or wind resistance caused by the fan or just moving the rotor of the motor through air. And there could be friction. So there are a range of other issues which require some of this energy to make the motor work. And they're a loss because all we want the motor to do is turn at the shaft at the output and give power out. The power out is always going to be less than the power in. So we have power in, losses, and power out. That's an important but very, very simple diagram. So let's talk about that. We can we can change this down to a formula. And efficiency equals power out divided by power in times 100. That will give you the answer in percent. We're using power here. I've used power on the diagram there. But we could talk about energy. We could do this in joules or other quantities, but power is the most common one, certainly for us. Let's do an example, but before I do that, I've just written F for efficiency. The correct the correct identifier for that is the Greek letter eta, which looks like a lowercase n with a long finish. So that is eta. I don't mind if you use that or that. I would mark either correct. Let's do a couple of simple examples. So example 1. In this particular system, I'll say that the input power is 1250 watts. The output power is 950 watts. Find the efficiency. So the efficiency is power out over power in times 100. Put the numbers in. Power out is 950. Power in is 1250 times 100. And if you put that into your calculator and work it out correctly, you should come to 76%. Okay. Just coming back to this, on your calculators, you can use the fraction button, which looks something like this up in the top left-hand corner. And here is your top line, and there's the bottom line. So 950 times 100 divided by that will work. Or you could do the fraction, get an answer for that, and then multiply by 100. But either way, you should come to 76%. Let's do a second example. So in this one, the output power, P out, is 155 kilowatts. The input power is 572 kilowatts. How do you find the efficiency? So efficiency equals power out over power in times 100. Put the numbers in. Power out 155, power in 572. Put it in your calculator, and that's 27%. Because this was in kilowatts and this is in kilowatts, I didn't write times 10 to the 3 there, and I didn't write times 10 to the 3 there, because it's the same unit top and bottom, so they basically cancel. So that's that one. Let me do one final example, then you can have a look at the questions on your handout. So the final example then. This involves transposition. So let us suppose we have a system where the efficiency is 80%. The input power is 5 kilowatts. And I want you to calculate, determine the output power. So start with your formula. Efficiency, you can start like that, or if you prefer, you can do the N. Eta is P out over P in times 100. So this is all division and multiplication, so we can use the crisscross method if you wish. The question asks us to find the output power. There is P out. We need the thing we want to find must be on the top line, so it's there. I've got to move the 100 and I've got to move the P in. So what will happen is that goes up next to that, and this is going to go down underneath. So the next line is going to look like this. Efficiency times power in, so that has moved up next to efficiency, and the 100 comes underneath, and that gives us power out. Let's just turn it around so that it reads correctly. Power out is, the efficiency was 80. Don't write percent, don't do anything with it. We've dealt with percent by moving that 100 there. So it's that times P in, which is 5 kilowatts, and divide that by 100. So if you put this into your calculator, you'll come with an answer of 4. Okay, this is 5 kilowatts, that's what went in, and this is 4 kilowatts, that's what comes out. So you need to remember that's kilowatts. Okay, so that is all fine and correct. Let me just revisit what I've just said. We could have written times 10 to the 3 there, and the answer here would come out as either 4,000 or 4 times 10 to the 3 in your calculator. But because I knew that we started in kilowatts, we would finish in kilowatts. If that causes confusion for you, then put these numbers in and it will appear here and there. Okay, get on with the questions.